The objective of this lesson is to add fractions with unlike denominators by replacing one or both fractions with an equivalent fraction. In previous lessons, students learned that in order to add fractions with unlike denominators, a common denominator must be found. They also learned how to create common denominators by multiplying the numerator and denominator by the same number. This was done with only one add-in in an addition equation. Today, students will use the same strategy to find common denominators with both add-ins. Although finding the least common denominator can make the computation more manageable, it is not necessary. Let's begin with our first problem. Maria's garden has two separate flower beds. 2/3 of one flower bed is covered in yellow flowers, and 4/9 of the other flower bed is covered in yellow flowers. What portion of her garden is covered in yellow flowers? The expression to represent this problem is 2/3 of one flower bed plus the 4/9 of the other flower bed. The two fractions do not have common denominators. A common denominator must be found in order to combine equal-sized pieces. The denominators 3 and 9 are related. 3 times 3 equals 9. 9 will be the common denominator. Multiply the first add-in, 2/3, by 3. Remember to multiply the numerator and the denominator both. The equivalent fraction to 2/3 is 6/9. When multiplying a fraction, the fraction is being partitioned into more pieces. The amount doesn't change, just the size of the pieces being considered changes. The new expression now reads 6/9 plus 4/9. 6/9 plus 4/9 is 10/9, or can be thought of as 1 whole and 1/9 of the garden is yellow flowers. Let's look at another problem. A carpenter needs wood trim for the floor in a hallway. He needs 1/2 a meter for one section and 1/3 of a meter for another section. How much wood will the carpenter use for the trim? The equation to represent this problem is 1/2 meter plus 1/3 of a meter equals T, the total trim. The fractions do not have common denominators, and one denominator can't be multiplied to look like the other. The denominators are unrelated. There is another way to create a common denominator by multiplying the two denominators together. For the first add-in, the denominator 2 will be multiplied by 3. On the model, this is shown by turning each 1/2 piece into 3 pieces. So now each piece went from having a value of 1/2 to 1/6. There were 2 pieces before in the whole, and now there are 6. 2 times 3 equals 6. The amount that was being counted also increased by 3 times as many. 1 times 3 equals 3. Therefore, the equivalent fraction to 1/2 is 3/6. The same process happens with the second add-in, 1/3. The denominator and numerator will be multiplied by 2. On the model, this is shown by taking each 1/3 piece into 2 pieces. So now each piece went from having a value of 1/3 to a value of 1/6. There were 3 pieces before in the whole, and now there are 6. 3 times 2 equals 6. The amount that was being counted also increased by 2 times as many. 1 times 2 equals 2. Therefore, the equivalent fraction to 1/3 is 2/6. The equivalent equation now reads 3/6 plus 2/6 equals T. T equals 5/6 of a meter of trim. Both of the problems completed today were practical to model because the denominators started small and remained pretty small when the strategy of multiplying the denominators by each other was applied. However, as denominators get larger, the modeling becomes more difficult, and it is easier and more efficient to use the strategy of multiplying the denominators. Let's look at one example where the denominators become a little more difficult to model. 3/8 plus 2/5. The initial model of each of the fractions is pretty simple. In order to add the fractions, a common denominator will be found by multiplying the denominators. The common denominator is 40, and the new equivalent equation reads 15/40 plus 16/40, and this equals 31/40. The denominator is quite large and becomes difficult and time-consuming to draw a model. While drawing out the model was correct, it was more effective to use the multiplication of the denominators method. The objective for this lesson was to add fractions with unlike denominators by replacing one or both fractions with an equivalent fraction. We met this objective by modeling the addition of fractions with related and unrelated denominators by using models as well as the strategy of multiplying the denominators. We found the multiplying denominator strategy was a more effective way to find common denominators than drawing a model.